Let's look at why you should consider installing a smoke control system in a building. Well, there's a number of reasons, and these are, first of all, you've got means of escape. You've got temperature control, maintaining the temperature of the smoke below a certain acceptable level. You've got to assist firefighting operations, and you've got property protection. So these are the main reasons. Now, we're going to look at these in greater detail in step 1. However, let's look at the smoke control systems in general. Now, smoke control systems generally form part of a package of fire protection measures, which may include heat or smoke detection, you've got smoke barriers, you've got fire-resisting construction and other methods to suit particular circumstances. So smoke control, it gives you part of a system. However, it's essential that the detail and the objectives of the smoke control system are consistent with the planning of the spaces within the building and the means of escape from it. The system should be as simple and reliable as possible, and it should be consistent with the objectives of the design. If you make it overly complex, it can lead to a lower level of reliability and it might not work. You know, some of these systems, like having a DVD player with 7,000 functions. Well, you've got 7,000 functions, you've got 7,000 things that go wrong. Sometimes the simplest one's the most reliable system. Now, there are a number of methods available to the designer for smoke control. And these are the common methods of smoke control. You've got smoke containment, you've got smoke clearance, you've got smoke dilution, you've got pressurisation, depressurisation and smoke exhaust ventilation. Now let's go through these one by one. Let's look first of all at smoke containment. Now, smoke containment involves the use of traditional methods of fire resistance, such as fire-resisting walls or fire doors or shutters, which perform the role of smoke control by simple containment. Now, smoke containment relies on physical barriers to limit the spread of smoky gases from one space in a building to another. Now, passive compartmentation such as doors, shutters, walls and floors can all provide some protection against smoke penetration. Now, the extent to which smoke leaks through these barriers depends on the size and the shape of the leakage paths and the pressure differentials across them. In a larger fire, it will create a greater pressure. It's more likely going to leak more than in a smaller fire size because it's got a lower pressure differential. Now, these leakage paths can be eliminated or substantially reduced by the incorporation of linear gap sealing systems. You've got penetration sealing systems, smoke control door sets and their associated seals. So that's what you can do, add more of these seals. And the control of high temperature smoke can be achieved with the use of intermittent seals. These are seals that expand at certain temperatures, expand and effectively seal off that opening. They typically go off 110 to 200 degrees. They expand and they seal it off. The next system I'm going to look at is smoke clearance, and this method involves removing relatively cool smoky gases from a space in a building when smoke is no longer entering or being created in that space. In other words, post-fire. Now, this can be achieved by providing natural cross-ventilation, for example, opening windows, or by the activation of powered exhaust systems. In the fire brigade, they use positive pressure ventilation, where they put huge fans and they push out all the air, but generally that's carried out. They can either be passive or active. That's generally carried out afterwards to get rid of the smoke. Now, next we have smoke dilution. Now, smoke dilution involves mixing the smoky gases with enough clean air to increase visibility and reduce the threat from toxic combustion products. However, this can require very large dilution rates to achieve a safe visibility. In other words, the amount of smoke you produce, you need a lot of air to dilute it sufficiently. So this is one method, but it's hard to achieve, especially with these smoky fuels such as those from plastics. This dilution may need to be 1,000 times the initial volume of the combustible gases, up to 1,000 times. And this can be difficult to achieve for all except the smallest design fires in a large building. So if you've got a very small fire, large building, possibly this system will work. If you've got a large fire in a small building or in a large building, it's not going to comply. You will not get that dilution rate. So that's when you can have those systems. Next, we've got pressurisation. Pressurisation is a form of smoke control using pressure differentials in which the air pressure in spaces being protected is raised above that in the fire affected area. So they raise the pressure above it in the protected area, so smoke coming one way will not go through there, as long as the pressure differential is higher than the pressure generated by the smoke. Now, airflow through the leakage paths prevents infiltration of smoke to the protected high pressure side. Now, the pressure differential across any small openings onto an escape route should be large enough, as I said, to offset the fire-generated pressures as well as any adverse pressures caused by external winds and the stack effect. So these are the things you've got to consider. Stack effect, you've got external wind pressures, but the main ones is the fire. What pressures are going to be generated, because it's got to maintain that over. It's got to be positive pressure above that. And it should also be low enough to allow the escape door to be opened with relative ease. So sometimes they pressurise them. They can pressurise them to 150 pascals, 200 pascals. Well, that's great. There's no smoke coming through there, I guarantee you now. But no one could open the door. It's too much. They can't open the door. So you've got to balance it out with maintaining this pressure that stops the leakage, but you've also got to be able to open the doors. Now, the requirements can be contradictory, and again, these are difficult to achieve. Now, pressurisation systems are designed to have adequate airflow rates across any large openings, for example, doors. And these excessive pressure differentials across a small opening when the doors are closed can be prevented by the use of pressure relief dampers, and you can also have ducts. So that's what they do for pressurisation. That's the principle. Next, we've got depressurisation. Well, depressurisation is smoke control using pressure differentials in which the air pressure in the space containing the fire is reduced. So rather than make one higher than the area protected, reduce the pressure where the fire is, below that in the adjacent spaces, so it makes the smoke go a certain way. Then gases are removed from the smoke affected space in a way that maintains the desired pressure differences across any leakage openings between that space and adjacent spaces. Now, sometimes in atriums it's possible to use the buoyancy of the smoke gases themselves to create this required depressurisation effects, but this is rarely the case. Very rarely they use this. Generally, you have to create these pressure differentials with fans, extraction fans, for example. And finally, we have smoke exhaust ventilation systems. Now, smoke exhaust ventilation is a method providing a separation between an upper layer of smoke and a lower layer of relatively clean air. Now, this is achieved by exhausting smoke from the buoyant smoke layer using either natural or powered ventilators and replacing it with clean air entering the space below the layer. Now, your hot buoyant gases from a fire rise to form a stable layer in a reservoir below the ceiling such that a cooler, clear layer of sufficient height may be present for long enough to achieve safe evacuation of occupants. Now, other specialist methods of extracting, you've got car park extraction, residential flat corridor protection, and these are covered later in the presentation. Now, that covers the options available